but problems come time after time. Just as you have solved one problem, you will face another one. And when they have solved the problem of data transmission within one wire between all of the participants number grows so fast, so it lead to the problem of how could we store all of the addresses that can exist in the whole network. So they have faced the problem that all of the participants had to keep the data table that stores the definite address of all of the computers that are connected to the same network. But the problem is that all of the computers could reconnect time after time. One or another computer could disappear, and you have to modify your table and keep it up to date all the time to make it possible to send data for the destination. And the conflict in addresses arises, and many other problems that have led to the situation when ARPANET resolved that they need to have one computer to store the whole table of all of the addresses that are available within the internet, or it was not the internet in this form that we see now, but the network of the computers, and to keep this data alive and sustainable and always updatable according to the current situation of all the connected participants. And starting from 1973 with only 60 computers and ending up with 1974 with 200 computers by 1977. And on the next slide, you can see a general schema of all of the participants within this network of the computer in 1978 that connected the West Coast and East Coast of United States, and even it already connected the London and Hawaii with the satellite data exchange. And at that time, many other networks appeared, and the problem was that all of the other networks, they tried to implement their own approach of how can the data be transferred to the participants, and all of them, they use different standards of the protocols and the standard frame of the protocols to data exchange, and it was not very easy to connect all of these sub-networks into a big one. So ARPANET resolved to create the standardized protocol of data interchange, and they name it as the TCP/IP protocol, where IP is the addressing protocol, where every participant have to have its virtual address that strictly rely on the MAC address, manufacturer address unique number, that we have already told during the previous lectures. And the internet protocol provided the way how can we deliver and receive the data from all of the participants according to the digital number. And the TCP, Transfer Control Protocol, was designed to organize the guaranteed delivery of each packet that is sent through the network. The general idea was that every participant computer forms the packet that consists of the address to the destination, the delivery address, and the sender address, and also the checksum that checks if this packet have been delivered to the final destination, or this packet died through the roads that it goes from the internet, from the network. And Transfer Control Protocol guarantees that if this packet have not been delivered to the final destination, the next packet repeating the same information will be sent by the initiator of a data transfer. The transmission control protocol became a standard and made it possible to connect all of the subnetworks into a big one, so that now we could have the real name of the internet, international network, that combined all of the subnetworks together.